Ladies and gentlemen, please put your hands together for our legendary Green MP and Econaut, Gareth Hughes!
Kia ora everyone, it's so lovely to see you all. Thank you so much for coming out on a cold winter's night. It's lovely to see you. Kia ora, ngā mihi nui, kia koutou kia ora. So I'm Gareth Hughes, Green MP and Econaut. Though people on Twitter looking at this picture they actually call me an eco nut. I should have thought that through, right? But it's true, I am a total eco nut. I've spent my entire adult life, 20 years working for first Greenpeace for a decade, and then 10 years in Parliament for the Green Party. You know, I've literally put my body on the line for the environment. I've campaigned, I've lobbied, I've protested, I've petitioned, I've got myself arrested, and I've got myself elected, all to protect the environment. That is actually me. I'm here because I love the environment and I love space. I'm really passionate about it. Now, it might seem a bit of an odd thing for an MP to be doing, you know, talking about space and the environment, but this has been my inspiration for all my environmental work, is that looking up at the wonders of space. A few years ago, the Royal Astronomical Society asked me to do a talk about it, and I've been developing the talk ever since. I'm really excited to share it with you because space is full of great stories and great imagery. Look, this is actually happening right now. This is live from the International Space Station. I've timed it wrong, right? It's dark. But isn't it incredible to think this is happening right now in real time? So I've always loved space. You know, growing up in Gisborne, I played Space Invaders and Space Lego. It's always been a part of my life. And this was one of my favourite books growing up. It's called The Usborne Future Cities from 1979. Do you know where they predicted the 2020 Olympics would be? The moon. Thanks to COVID, we're not even having the 2020 Olympics in Japan. And as someone who thought, you know, maybe I could do the high jump on the moon, I don't know what's more depressing as a slightly overweight 38-year-old, the fact I'm never going to compete in the Olympics or never go to the moon. But it was out for me when I was on the Rainbow Warrior out at sea, where I'd stare up at the stars at night, that I really gained a love for the stars, and it's so beautiful and crisp in the middle of the ocean. It's such a special taonga. So astronomy's always been a passion of mine, and I'm really excited to share it with you tonight. And I think actually we can open some more insights for some of our problems down home. So I should first up clarify some things, right? I'm almost about to leave Parliament after 10 years there. And so this isn't a political communication. Actually, it's not electioneering. I'm not going to ask you to do anything political whatsoever. Or am I? Maybe ask you to join the Greens. Hey, Jonathan, lock the doors! And for any parents out there who maybe thought, actually, it was the Octonauts. It's not. So what is an Econaut? For me, it's a word I've invented to cover two of the passions I've talked about. For me, it's about the fact that space and looking up can give us the tools, the technology, the insight and the inspiration to protect this world of ours, which we need more than ever in 2020. You know, really it's about astronomy and environmentalism. I wanted to call it the astro-environmentalism. But I thought, well, that sounds a bit boring, doesn't it? You know, it's kind of like nagging about recycling and vegan meals and drinking your own urine on the International Space Station. That all happens, by the way. Then I thought, well, what about the astro-mentalist? But that sounds more like some sort of time-travelling wizard who goes around solving crimes. So I've settled on Econaut, and I hope you'll actually join me as an Econaut. So why on earth is this former clown, and the soon-to-be former Member of Parliament, going around calling himself an Econaut? This is where I live in Otago. This was actually taken by a friend in my suburb on the Otago Peninsula. Isn't it beautiful? And for me, I find inspiration for my work to protect the environment from places like this. Anyone know who this guy is?
Yeah.
The song goes, Captain Planet. So growing up, when I was 10, this guy first entered TV in 1990. When he first entered TV, it was the first time we'd seen environmental messages, you know, in prime time. It showed that the environmental movement was becoming mainstream. It was becoming cool. You know, we were starting to fix the problems. But this is an amazing fact, and I've only recently discovered more emissions have entered the atmosphere, more pollution, since Captain Planet was on TV than all the 250 years of the Industrial Revolution before. And I say this not to, I say this because the stuff I'm talking about tonight isn't theoretical, and it isn't distant from us. What I'm talking about tonight is about us, and it's about our generation and our home. So here's my favourite ever space image, taken on Christmas Eve, 1968, on Apollo 8. You know, it's surprising because we see this image all the time today, but imagine seeing it for the first time, the Earth from space, the whole Earth. You know, it's kind of like seeing a mirror for the first time. It's been described as the most influential environmental photograph ever in history. And I love it, right? Here's this beautiful blue globe, you know, all our love, our life exists on that ball. But you also see the fragility of it. Here's this paradise, this oasis, in the hostile vastness of space. And it was the astronaut who took the pic, Bill Anders, who said, we went to the moon on Apollo to explore the moon. Actually, what we ended up exploring was the Earth, which I think is amazing. And this picture's been on my wall in Parliament for many, many years. Here's a more modern version from the Japanese Space Agency, which stitched some of these images together. Now remember, everything we depend on for life happens here. All of our life support system, it's a totally closed ecosystem. You know, clean water, fresh air, warmth, all happens here on our planet. Now, why I also really love this image is it challenges the basic assumptions that run our society and our economy. It's clear, right? The Earth isn't growing. There is no second Earth we can go harvest extra materials from. I'll have to fix that. Bloody parliamentary services. Hey, Jonathan, what's your email? What's your password? What is it?
RIN?
I actually know what it is, but it's such an embarrassing password that I want to rainstorm cloud burst. Rain, storm, cloud, burst. There we go. What was I talking about? Earth. You know, it's clear that it's not growing, right? Yet we try to have infinite economic growth on this finite planet. You know, according to the WWF, if every single person on Earth today consumed like we do as New Zealanders, we would need 5 to 7 Earths worth of resources and energy to keep at our living standards. And that's why tonight's talk is dedicated to my friend, my mentor, the late Jeanette Fitzsimons. You know, she was a politician who had the courage to challenge that orthodoxy, right? This thing that we take for granted, that we'll always have infinite growth on a finite planet. This is why it's dedicated to her who had that courage. So let's start, eh? Ever since, you know, we first looked up at the sky and the stars and the planets and the moon, you know, we've always gone, wow, you know, ha. In New Zealand, we're famous for our stars. We've got Taika Waititi, Lord, Chloe Swarbrick. Sorry, you're going to notice there's some dad jokes in this presentation. But it's true, we are incredibly famous for our stars. And we've got Margaret Austin, who's been a former Member of Parliament and someone who's been intimately involved with the dark sky movement here. International tourists actually said it was the #1 memory they took away from visiting New Zealand, was seeing the night sky and seeing the stars in the Milky Way. And we had the first ever dark sky reserve in the Southern Hemisphere. So we are famous for our stars. And we're all here in Aotearoa, New Zealand, because the stars guided our ancestors, no matter who they were. Now I've got a bit of a tip, because I know a lot of people don't know this, but if you're ever lost and you need to find south, all you do is you take the Southern Cross and the pointer stars, you draw a line down from the Southern Cross, a line from the pointer stars, and where they meet, that's south. You can always find your way home doing that. Now, unlike those fancy fat cats in the Northern Hemisphere who are North Star, we have to use the self-celestial pole. And you can see it in this image, again taken from my suburb in Dunedin, how the sky rotates around the self-celestial pole. Isn't it beautiful? This is a time-lapse image. Now, I've got a pop quiz for you. Does anyone know the average colour of the universe? I'll give you a sec. You're thinking green, right? Actually, the average colour of the universe is this. It's beige. So, scientists from Johns Hopkins University combined the light of 200,000 galaxies within 2 billion light years of Earth. They averaged the colour, and this is the colour of the universe. As our cricket team and their former uniforms used to show, no one looks good in this colour. Except one man, rocking a beige turtleneck. One of my heroes, my other inspiration for this presentation tonight, Carl Sagan. An amazing scientist, an amazing science communicator, and also close to my heart, very pro-cannabis. You know, communicated the wonders of the universe. And when you look over just the last few years, we've first discovered and then solved why there's a hexagon at the top of Saturn. We've discovered more than 4,000 planets orbiting other stars in our galaxy. We've found planets with the density of cotton candy. We've found sugar molecules in space. We've found planets where it rains diamonds. Isn't that incredible? I just find this amazing stuff. But also it's amazing that we as humans go, sure, right? Space is beige, and there's planets that rain diamonds and sugar clouds in space, and we nod our heads and go, sure, the scientists have worked it out. But when some people hear scientists say, well, climate change is happening because of fossil fuels, they say it can't be true because it was cold last week. So when Carl Sagan died in 1996, this was the best image we had of Pluto, using our most powerful telescope, the Hubble. This is what we have today, which I find amazing. Last year, we got the first ever image of a black hole, or more accurately, the event horizon around it. Now, can you believe it? It took 8 supercomputers on Earth to capture this object, which is 55 million light years away, and people on Twitter went, but it's blurry. That's partly why I'm giving up politics, right? Because of all the trolls on Twitter. But you can't complain about this picture. I dare anyone to complain about it. It's called The Pillars of Creation from Hubble. It's just amazing. Something interesting I've learned recently is these pictures don't come out of the telescopes looking exactly like this. There are people whose job it is to keep the accuracy, what they're seeing, but also make it a bit more appealing and colorize it. Do you know one of the job titles is Master of the Digital Universe? Isn't that a cool job title? It's just amazing. So, I mean, I put this up because this is us, right? This is our environment. And sorry to put you on the spot, but can I ask what your name is and how old you are?
Scott, 31.
Kia ora, Scott. Would it be offensive if I told you you're actually 3 billion years old? Because it's true. I mean, all of the atoms in our body are around 3 billion years old. I mean, we come from star stuff, and that's what has been written about us. I mean, every atom in our body came out of a supernova where a star reaches the end of its life and spreads its material through. Now, a couple of years ago in Parliament, one of my little achievements was passing the Country of Origin Food Labelling Bill, which means that once the regulations pass, from next year, most foods in New Zealand are going to carry a label saying where the country of origin is. But given you're 3 billion years old and I'm 3 billion years old, I wonder if I didn't go far enough with that piece of legislation. Because, I mean, take this bag of Canterbury Matariki coffee, you know, locally roasted, organic, fair trade, wonderful stuff, contains many compounds essential for life, including caffeine. You know, everything in here, the iron, the zinc, came out of an exploding star. Everything in our body came from that. And I find that just an incredible fact to be thinking of. Now, we can tell a lot about what's out in space by colour. And we can actually tell a lot about what's inside a star because of colour. Now, when you look at the colours of stars, red stars are cooler than blue stars, which are cooler than white stars, which are cooler than blue stars. Now, what that means is green is in the point in the spectrum between blue and red. I like to think green's more to the left of red, but we'll put that aside. So green is right in between, and when white light is being shone, actually all the colours of the spectrum are coming out. And this is why you never will see a green star in space. But also you'll never see a purple star, but that's not important this election. Bit of an older joke, that one, I think, from a little question. But I want to do a bit of an experiment for you. I'm partly doing this too because politics can be so boring, and I've done so many cold talks and drafty church halls. I wanted to try and make politics and political communication a little bit more interesting. So I've got a bit of an experiment for you here, because how do we know that it's raining potentially diamonds on Neptune? How do we know there are sugar clouds in space? Now, colour is a real key to what's going on, as we learnt with the star example before. Now, I'm going to need glasses for this experiment, because every element has a unique colour signature, and scientists use a tool called spectroscopy to work out what's going on, because once a photon of light, like coming down here, hits an atom, a small amount of energy is released, in the form of colour, like a colour signature. It's like a fingerprint. And using colour, we can work out what's happening on stars, other planets, other atmospheres. And could we dim the lights for this one? And what I've got is a few different materials in these jars, and what you're going to see after a little bit of time is them all burning different colours. So here's potassium, here's sodium, here's copper, here's calcium. Calcium's not burning. After Hamish Walker, I'm thinking that maybe politicians shouldn't play with fire. But these are going to, you see they're burning different colours? This one would have been a lovely green as well. And so this is how we know what's happening. Now, I show this because I find this amazing, that we can work stuff out from really simple principles like colour and colour signatures. And actually, this is how we might find life in space. Really big deal. So this is Oumuamua. We only discovered a few years ago. It's this isn't a photograph, this is an artistic rendering of it. So Oumuamua is this really long, really thin object which is travelling incredibly fast through our solar system from outside. It's the first interstellar visitor we've ever discovered. Now, of course, people jumped on Twitter and went, "It's an alien probe." It's probably not. But it is an interesting question, when will we find life? And it might happen in our lifetimes, which I find incredible. But I think the lesson, and my message to you is, the way we find life probably won't be a flying saucer landing on the White House lawn. I think there's already an alien inside there, right? And it won't be the GCSB listening in on alien telephone conversations. I think the highest likelihood we're going to find life in space in our lifetimes is by finding pollution. Now, what I mean by that, and I'm not a fan of pollution, obviously, but when this thing launches in a couple of years, it's called the James Webb Space Telescope. It's going to be the most powerful telescope we've ever put into space. It's going to be so powerful, it's going to be look into the atmospheres of those 4,000, probably billions of planets in our in our galaxy, and it's going to be able to find the colour signature of what's in those exoplanet atmospheres. Isn't this incredible? We're going to be able to see what's in an atmosphere of a planet orbiting another star far out in the Milky Way. Now, if we find something like ozone, oxygen, and nitrogen dioxide, we have found life. We will know we have found life if we find the mix of those chemicals, because only life can create it. Now, if we find artificial chemicals which can only be created in a factory, like fluorinated gases, we have found evidence of advanced life. I find this an amazing fact. And this thing's launching soon. There's actually a project in New Zealand where we might launch up a few mini-sats using Rocket Lab, which could look at the Matariki, the Pleiades cluster, and we might get there first in New Zealand. There's a serious proposal on the table asking for some government support, which I'd love to see. But isn't it also sobering to think maybe someone's looking at our atmosphere right now and seeing all the chemicals and pollution we put up there? They know all about us just by reading the colour signature of our atmosphere. Will we find life in our solar system? Who knows? But scientists often say, to find life, you've got to follow the water. Now, when I was growing up, we thought water in space was incredibly rare. Those were the books I was reading in the National Geographics. But now we know that water is everywhere, from Mercury, the closest planet to the sun, all the way to Pluto, the furthest planet from the sun. We found a gigantic subsurface ocean on Jupiter's Europa. We found it on Jupiter's Ganymede. We found another big ocean on Saturn's Enceladus. Even on Dawn, the tiny dwarf planet, I mean, this is so small it's not even a planet. It's not even fully round. We've found evidence of an ancient cryovolcano. What I mean by that is this is a gigantic volcano on this tiny little dwarf planet that was historically spewed out lava, but it wasn't lava, it was water ice. And actually research published last year showed that water is driving active changes on this dwarf planet today, which is amazing, right? So we've spent all this effort and we've now discovered water everywhere. Now this is Mars, the only planet we know of that's solely inhabited by robots. They're our robots, it's all right. Now Mars, like Earth, once had liquid water. It probably had significant oceans, and we've found heaps of evidence for it. But because it's so small and its atmosphere couldn't hold it in, it lost its water. But recently, 2 years ago, the Italian Space Agency discovered evidence of a 20-kilometre subglacial lake under the poles. So on Mars, we've even found water there, which is incredible. But what we often hear from tech bros, like Elon Musk, is, well, this is our new home. We've got a backup. And people even say, like Elon Musk, the only way humanity's going to survive is if we colonise Mars. Now, I've got two rebuttals to that. Because the first is colonisation didn't work out too well on Earth, did it? And the second is, it's kind of an analogy. Like, why would you move from this great house with good insulation, it's got a heat pump, clean water, great garden, beautiful views, to move to an airless, freezing cold, totally radioactive, hole in the ground that the dust is toxic and would kill you, just to avoid cleaning up your house in the first place. So this is why I'd love to explore the cosmos, but Mars is no backup. Mars is no planet B. Because we've got this beautiful, pristine paradise already. Now, if aliens do ever come and visit Earth, I don't think they'd call us planet Earth. Looking at this photo, they'd call us planet Ocean, because ocean covers 71% of our land surface, which we know so well down here in New Zealand. It's incredible, though, to think that we still don't actually know where Earth's water came from. So scientists for a long time thought, well, it came from asteroids and comets in our past, and that's where all the water was brought to Earth. But actually, scientists analysed isotope elements of protium, deuterium in 4 different comets to see if it lined up with our water on Earth. Now I'm going to try and remember the asteroids. It was Hyakutake, Hale-Bopp, and 67P Churyumov-Gerasimenko. And they found it didn't line up. It didn't line up with our water. But recent evidence actually suggests the water is primordial. The water came from our rocks. What that means is our water is ancient. We're an ancient watery world, blessed with the stuff. But here in New Zealand, we treat the stuff like rubbish. We spent billions of dollars trying to find it in space. It costs millions of dollars to get it to the space station. Yet in New Zealand, 2/3 of our waterways you can't swim in, or you risk getting your kids sick. We've got the equivalent of 60 million people with our dairy herd, putting 60 million people's worth of untreated effluent in our waterways every year. And every year we lose 200 million tonnes of our most precious resource, topsoil, stuff we use to grow plants that feed us, out to the sea because of our land use practices. So, when we look up and wonder about water in space, let's also wonder about protecting it down here on Earth. So let's go below the ocean for a sec. This is footage from the deepest point in the oceans, and this is a new species of sea squirt. So this is a cool story. So Victor Vescovo, he's this American explorer, and last year he went to the 5 deepest points in the world's 5 oceans. In the Pacific Mariana Trench, 10,927 metres below sea level, where the pressure would crush us in an instant, guess what he found? Plastic bag. Can you believe it? He went to the most remote place possible on Earth, and there he found a plastic bag. According to the Ellen MacArthur Foundation and the World Economic Forum, by 2050, if current trends continue, there will be more plastic by weight in the oceans than fish by weight in the oceans in our lifetimes. But it doesn't have to be that way, and we can turn things around. And look, as a Green, I'm incredibly proud of the work Eugenie Sage has been doing as the Minister for Waste. And since the plastic bag ban, 1.1 billion plastic bags in New Zealand have been avoided from going into the environment because of that decision, which we're all part of. So there's some good news too. Now I've got a bit of a personal deep sea tale for you here. It was 2005, I was sailing on the Rainbow Warrior in international waters in the Tasman Sea. We were doing exciting stuff. We were out there to stop deep sea bottom trawlers from being able to fish. Now deep sea bottom trawling involves dragging large nets, some as big as 747 aeroplanes, up and down the seafloor to try and catch fish like orange roughy. Fish we only discovered in the 70s. And I was there the day we filmed New Zealand fishermen ripping off the seabed and throwing overboard this 500-year-old Gorgonian coral off the seafloor. They just threw it in the water dead. Now it was quite surreal because we're bobbing out in the middle of nowhere, only albatross around us. And I remember one of the fishermen yelling at me, "Hey hippie, get a real job!" And they were pretty annoyed, right? And they were putting their fire hoses on us. They were even built a mortar to hurl potatoes at us. When we got close, they'd throw their fish at us. But we caught all the fish, we tried to retrieve it, and the marine biologist aboard our boat was rapt because some of them were fish he'd never seen before. We spent about 15 minutes though chasing this one particularly, what we thought was a fish. You know, it was quite rough seas. We took 15 minutes to finally catch up to it, hauled it on board, and guess what it was? It was a giant piece of plastic insulation. From the depths of the ocean, where it's like pitch black, where the pressure would crush us in an instant, plastic waste had got there. I remember a crew member on board who told me, who'd been sailing in the Arctic, he once saw a Coke can embedded as an iceberg as he sailed past it. Now, while we're talking about what's happening in the oceans, this is what's happening above our heads. And this is a graphic demonstrating the growth of space waste. New Zealand's actually playing a leading role in tracking this stuff now. In Naseby in Central Otago, Leo Labs has one of 3 satellites which is tracking now 250,000 objects that actually pose risk to our satellites in the space station. So just stop and think for a moment. We've put plastic in the deepest depths of the ocean. We've got junk orbiting hundreds of kilometres above our heads. We truly are having a planet-sized environmental impact, us humans. It was only 1977 we discovered these, the hydrothermal vents, the black smokers, and we discovered a new way of powering life that was totally separate from the sun, using the energy reserves of the Earth. Can you believe it though? There's an old mining application in New Zealand to bulldoze these things to try and get the minerals out of them, which I find just incredible. What will we find on Enceladus or Europa if we ever get to those planets one day? Our own deep is full of these amazing alien-like creatures. And my favourite? It's actually a photo of me at the end of 10 years in politics. Is there alien life out there? I mean, who knows? But it's something my man Carl Sagan explored in the book he wrote, which was turned into a movie, Contact. It was Arthur C. Clarke who once said, well, there are either 2 possibilities that exist. Either we're completely alone in the universe, or we're not. Both are equally terrifying. It was Enrico Fermi, who was a physicist who worked on the Manhattan Project, the project to build the atomic bomb. And there's a great story. He was having lunch with his physicist friends in 1950. And there'd been flying saucer sightings, and they were reading about it in the newspaper. And of course, being physicists, they did the maths and were working out, the distance between stars and how fast they'd have to go, and was faster than light travel even possible. And during the middle of this lunch, he blurted out, "But where do you wonder everybody is?" And that's become the Fermi Paradox, which is this idea: look, we've got billions and billions of planets in space. Why is there no life? There's no signs, no relics, no messages. Are we alone? Why this great silence? The Fermi Paradox. Now, we do know there is some life in space. Now, I hope this isn't too controversial, but I'm going to try something live. I'm going to dub, how many people are in space right now? There we go. 5. There is life in space. They're humans, though. And the Fermi Paradox asks a big question, where are these aliens? And I've got another bit of a demonstration for you. Now, it would not be a science space talk without a little bit of maths. So what I'm going to run you through is a thing called the Drake equation. This is a way to try and work out, how many planets could there be to deal with this thing, the Fermi Paradox? So this is how the equation, remember these? This is what I learned. So to get the answer n, can you see that all right? Which is the number of potential civilizations that are in our galaxy alone, you do a calculation. So you've got R, which is the rate of star formation. How many stars, we know that pretty well now, times the fraction of those stars that have planets, which we know. I think for every, no, I won't give you the wrong figure, but basically I think there's around 3, no, I won't. There's a lot of planets out there. Times the fraction of planets, times the number of planets that have suitability for life, the Goldilocks zone, which we know of, times the fraction where life emerges, that actually grows, times that grow and turn into civilizations that actually send out signals that we could detect, times the length of time, and that equals n, which is the estimate of civilizations. So Drake originally estimated there was between 100 and 100,000 civilizations in our galaxy alone. There was a report published 2 weeks ago that said there was 36, which I find oddly specific. But anyway, I mean, we will never know what the actual figure will be. But this is the question of, where's my pointer, of the Drake equation. So I've talked about the Drake equation and the Fermi paradox. Maybe the answer to the Fermi paradox is that the key variable L is actually very short. Maybe advanced civilizations, they do grow and they do, send out signals, but they don't do it for very long. We've got some experience with our own planet. I mean, remember that time another planet bowled into us and we got a moon? Luckily we avoided that one, we came a bit later. All the time a gamma ray wiped out 90% of life in our oceans. Luckily again, we were a little bit after that one before it happened. All that time the asteroid hit and destroyed the dinosaurs. Now this is really interesting because some recent research has just been published saying, sure, the asteroid had a big impact, but it wasn't just the fact that it hit the Earth and it caused a nuclear winter and a dust cloud. It was the fact that the Yucatan Peninsula, where it hit, this is called the Chicxulub crater, actually hit a massive ancient limestone deposit. And what that meant was that the crater incinerated that limestone, which has stored carbon, stored dead sea animals, and that changed the chemical composition of the oceans. It set off ocean acidification, and that's what actually wiped out the entire marine food chain, which wiped out all the most of the terrestrial life as well. Now I've got another experiment for you, and I'm going to need my gloves for this, because ocean acidification is happening right now on Earth because of all the carbon we're putting into the atmosphere because of carbon dioxide. The oceans are actually absorbing most of the carbon we're putting up there, and it's actually making the oceans more acidic. Now this is a liquid of what's called universal indicator. It's a pH and acid neutral proxy for our oceans. Can I have a volunteer? Would you like to come up? Yeah. You've got to wear these, and you're going to have to wear these. Do you want to put that on? Is that all right? No. I love playing with dry ice. So dry ice is basically carbon. So what we're going to do is doing a mini experiment of ocean acidification. Do you want to drop that in? Make sure you don't touch it with your skin. Put heaps in. Let's do it. We're putting heaps of emissions in the atmosphere. This is what we're doing to our oceans. We're adding all this carbon. I think that's enough, eh? Thank you very much. Should we give them a hand? Now that's going to settle down soon, and what you're going to see is the colour of that liquid change, because what's happening is the water is sequestering, storing the carbon, and it's changing the acidity level. There was a report published in New Zealand that actually said it's already impacting some of our shellfish exports at the moment, and this is a huge risk in the future because we're changing the ability for mollusks and other sea critters to be able to store calcium and make shells. So we've got no choice about asteroids or gamma rays, and luckily they were well in our past that they've meant we've been able to get through the Drake equation to where we are today. But there are some things happening now, and maybe this is the answer why other civilizations haven't got through. Maybe other civilizations that did emerge out in our galaxy, like us, discovered fossil fuels, and they set off catastrophic climate change. This is a graphic which shows the annual temperature change globally from 1850 to 2017. Do you see a trend in what's happening? And it's because of planetary scientists we were first tipped off on the warnings of climate change. Here's Jim Hansen, who was studying Venus and watching the runaway climate change in effect there. And he took that knowledge to warn the world governments that we were doing runaway climate change on Earth as well. So Venus, this is a photo from Venus, is Earth's sister. It's about the same size. We think that Venus once upon a time had liquid water, had oceans just like Earth. But what happened to it? Runaway climate change. What happened is, as it got hotter, the ocean started to boil off, adding more insulation into the atmosphere, leading to more of the oceans to boil off, until eventually there was no water left. And now today Venus has 96% carbon dioxide in its atmosphere. This is one of the only photographs we have of Venus because our probes keep melting. It's not the closest planet to the sun, but it is by far and away the hottest because of the runaway greenhouse gas effect. Now, if you pick up the newspaper, you see that Siberia is burning on Earth right now. In fact, the average temperature, I believe, this month is 18 degrees above the century level average before. According to the UK Met Office, we might temporarily pass 1.5 degrees within the next 5 years. Now, 1.5 degrees is that limit world governments have signed up to, a sort of global red line where you don't want to go over it, because what happens is you risk losing control of it and seeing, that's cool, you know, it's going to be fizzy and actually quite tasty to drink afterwards. We might pass that 1.5 degree threshold temporarily in 5 years. And why that's dangerous is these what are called climatic tipping points might emerge. So for example, the Amazon is becoming increasingly dry because of climate change. What that leads to is that potentially burning, releasing all that stored carbon in the soil and the forest, furthering climate change. Likewise with the Arctic melting, we're seeing that beautiful white ice which bounces the light, the heat, much of it back into space, turn into dark oceans. We're changing the planet's albedo, which means we're absorbing more heat. And then we're seeing things like the methane, a very powerful greenhouse gas, come out of the tundra in the northern hemisphere because of the melting temperatures. I feel I'm being a bit, it's quite cool though, isn't it? So we've got to try and avoid the lesson, the warning. I feel I'm being overshadowed. Hey? No, it's funny. It's great. But I want to show you a bit of a live demonstration what this question of adding more fossil fuels and more carbon to our atmosphere could actually mean.
Imagine this glass of water represents the amount of CO2 in the atmosphere in 1850. Now this is a good thing. If it wasn't here, it's estimated Earth would be as much as 35 degrees colder. However, by 1950, human beings had increased the amount of CO2 in the atmosphere to levels higher than it had been in over 100,000 years. Now today, we've added so much CO2 to the atmosphere that we're locked in for a temperature increase of close to 1.5 degrees as a result. Scientists have said CO2 levels any higher than this could cause catastrophic climate change. Increases in the Earth's temperature will struggle to adapt to. But of course we've already found considerable amounts of fossil fuels that we haven't even burnt yet. Let's add it in, shall we? So that's not good. That's more CO2 than the planet has seen in 420 million years. Yet according to oil lobbyists and oil apologists right here in New Zealand, we have to keep digging. You know why? Because of the sheer amount of money it's going to make them. Alright then, let's add all these unexplored reserves to the glass, shall we? So yeah, not a good idea.
That was fun. And this has been a trend of my career, and something I'm incredibly proud of is negotiating the end of the oil and gas offshore exploration ban. And I'm also incredibly proud that, you know, in government we've actually worked incredibly hard to stop fossil fuel exploration, and we've got a great opportunity to invest in clean energy to keep those fossil fuels out of the atmosphere. So I've talked a little about, is climate change the reason why that L variable is very short, that actually we burn up too much of the stored fossil fuel. Now another, and I think this is a symptom related to it, is this idea I talked about earlier about trying to have infinite economic growth on a finite planet. Now this is a thought experiment by an investment banker called Jeremy Grantham, who was talking to a whole bunch of mathematicians, and he said, do you ever stop and think how crazy it is that global economies try and grow at 4.5%, which is what many aspire to, including New Zealand. And he challenged them and said, well, imagine ancient Egypt. That lasted for 3,000 years. What size would the ancient Egyptian economy be at the end of 3,000 years, growing at 4.5%? So he challenged them in a thought experiment. So imagine King Nama, the first king of Egypt, had a chest of stuff that was 1 meter cubed. That's how big his chest was. How big do you think that chest would be at the end of 3,000 years? Nuts. I mean, big as Egypt, big as the earth, big as the sun. Now I want this to come back on. Because you know what the actual answer is? My pen. Thank you. So, after 3,000 years between King Nama and Queen Cleopatra, now I know why we stopped using these things. Anyway, the answer's going to blow. I wanted to blow your mind, because the answer after 3,000 years is 1,580 suns. Actually, it's 1,580 octillion suns. Now, I had to Google what an octillion was, and this is what it is. 27 zeros. That's how big square kilometres, it's how many suns it would take, that chest would be after 3,000 years. It just shows that, it's madness. Yet this is the system that we run our economy, and why I'm so appreciative of Jeanette's mahi. And maybe, because we've only tried this extreme growth on the planet for a century with most countries, why we're seeing such an impact on our environment. According to the most comprehensive global stocktake of the global environment last year, it found that we little humans, we've modified significantly 75% of the global land surface. We've destroyed 85% of wetlands. Only 3% of our oceans are unmodified, meaning we've modified 97% of it. And 1 in 8 species, or 1 million species, are on cusp of going extinct in our lifetime because of the pressures we're putting on the environment. The analogy I use is we've got this beautiful planet. It's kind of like a life raft. We need it for our survival in the void of space, yet we're like poking holes in it actively. So moving on to another question about Al. Now, in New Zealand, we say that climate change is our nuclear-free moment, but we forget that most other countries haven't had their nuclear-free moment. There are 14,000 nuclear warheads pointed at someone today, and we shouldn't forget that, because it's people like Carl Sagan, who in the 70s and 80s actually warned governments who thought, we could just launch a few nukes and it'll be fine, how devastating nuclear war would be and how bad a nuclear winter would be for the planet. You'd think this is Mercury or Mars. This is actually the Nevada nuclear test site. And this is a good fact if you're ever in a pub quiz and they ask. But actually the first object in space probably wasn't Sputnik, it was a manhole cover. So in 1957, they were testing nuclear devices in these shafts. One of these shafts was 485 feet, and for some reason they thought, well, we've got to put a lid on it, right? So they put a half-ton manhole cover on the top. And they detonated the device, and the manhole cover was nowhere to be found. And they were arguing, did it explode? Where did it go? And they actually, an astrophysicist, set up a slow-motion camera for the next nuclear test. And what they found is this thing shot up into the air, and it's actually probably the fastest thing humans have ever made. Using modern supercomputers, they estimate it passed Pluto in 1961 in only 4 years. It took our fastest ever spacecraft 9 years to get to Pluto, the New Horizons. Isn't that amazing? I forget the number off the top of my head, but it's the fastest ever. Now this looks like art, but this is actually an aurora created by the time we nuked space. What I mean by that is the US and Soviet governments detonated a dozen nuclear weapons in space. This is from the 1961 Starfish Prime test just above Hawaii. Sounds like a transformer, eh? Starfish Prime. This test in space actually took out 3 satellites that were orbiting Earth and even destroyed electronics in New Zealand at the time, which is incredible. I don't know who thought it was a good idea to just explode bombs in space, but can you believe in the 50s the US Army actually wanted to detonate a nuclear bomb on the moon to try and test and work out what the moon was actually made of? Luckily Project A119 didn't go ahead, but actually we only found out that they were even planning this in 2000 when Carl Sagan's biography was published, because as a young scientist he had actually worked on this project doing the theoretical impacts of what nuking the moon would do. So the final point is we often don't talk about nuclear weapons in New Zealand because we're proudly nuclear free. But we can't forget that there are still 14,000 nuclear warheads out there, and they do pose an existential threat to us on Earth. So there you go. I've talked about gamma rays, asteroids, acidification, climate change. Have a good night. I'm sorry, I couldn't do that. I want to leave you with a bit of hope, because space has actually got wonderful stories and examples of how we've dealt with global challenges. You know, in New Zealand, we know all about the ozone hole, right? We know all about it because of the impacts it's had on this country. But remember, it was only 1976 we first discovered, thanks to the use of satellites, what the ozone hole's extent was and what was causing it, CFCs, fluorinated gases. Within 11 years, most world governments had signed up to the Montreal Protocol, massively reduced the amount of CFCs we're putting out, and the hole's been healing ever since. You know, we have examples from our history where we've worked together, grappled with seemingly impossible challenges, and solved it. Now, we also can't forget that stuff can change incredibly fast. You know, this is why I've been an environmentalist for 2 decades. I'm really optimistic about the future. You know, for 2.6 million years, this was our most advanced technology. 150,000 years ago, this was still our most advanced technology. Then 7,000 years ago, we started using copper. 5,000 years ago, we started using iron. 3,000 years ago, started using, iron, it was bronze. 2,000 years ago, we started using steel. We created paper. 1,000 years ago, we invented paper money, rockets, glasses so we could see. 400 years ago, Galileo invented the telescope so we could see the heavens. 200 years ago, Michael Faraday invented the electric generator. 100 years ago, the Wright brothers first took flight. And then 70 years later, we reached the moon. Isn't it amazing? For millions of years, we went from rock to slightly better rock, and then in a single lifetime, we went from flying to the moon. Now, when John F. Kennedy in 1961 said, we choose to go to the moon in this decade and do the other things, the US only had 15 minutes of manned spaceflight experience. Imagine setting such a goal, like we're going to go to the moon in 9 years, when they've only done the thing for 15 minutes. They didn't even have the rockets. They were literally metaphorically building the rockets as they were flying them. And 8 years later, they landed on the moon. As I talked about with the UK Met Office and the climate data, scientists have said we have about 10 years to massively turn around our emissions so we don't lock in those tipping points, so we avoid 1.5 degrees. We have done amazing things in less time, and I believe we can tackle big problems like climate change as well. And I think there are some lessons from the mission to the moon that we can take for our equivalent mission, which is saving our planet from climate change. Do you know the average age of people working on the Apollo project? It was 27. Today, when you look at who's leading the climate movement, it's young people, people like Greta Thunberg. Today at NASA, it's 47 is the average age. I think the lesson is we can look for leadership from our young people. The second lesson is it is going to take money. It's going to take a big investment. There was a recent inflation-adjusted estimate of the Apollo project that put the total cost of getting to the moon for a decade at $490 billion US dollars in modern terms. Huge, huge. But do you know how much the world government spends on fossil fuel subsidies every single year? 600 billion. We spend more in a single year subsidizing pollution than we spent over a decade getting to the moon. And that's why I'm so proud that the Greens in government have negotiated the end of fossil fuel subsidies. The previous government was giving $60 to $80 million a year to oil companies in New Zealand. We've got a green investment fund with $100 million. We've got a Zero Carbon Act, 100% renewable electricity target. We're investing in the right things. Now the lesson is from those investments come amazing technology. They went to the moon with less power than I have in my pocket, which is a common cliche, but we would not have modern computing without Apollo. This is Margaret Hamilton and the code she wrote. But do you know, she wasn't coding like this all the time. The Apollo guidance computer was actually hardwired. It was more like weaving. They were literally weaving the software into the guidance computer. But out of this investment came new technologies. You know, from the first solar panel in space with Vanguard 1 in 1957 to the use of solar today. Do you know, just in my lifetime, I'm 38, the price of solar has dropped 99%. In New Zealand today, every 25 minutes, a new solar panel is installed on someone's roof. And we're going to announce some pretty amazing stuff this Sunday with the Green Party's energy policy. We've got smart Kiwis like Dr. Justin Hodgkiss at my old university, Victoria, who's using lasers and nanotechnology to produce printed solar panels. At Victoria University, they're developing aluminium batteries, which are much more greener, much more sustainable, much more easily recyclable than lithium batteries. They may even store even more power as well. There's smart Kiwis like friend of mine, Dr. Greg Bodeker from Alexandra. I love this about modern New Zealand. He runs global network of satellites from Alexandra. He's paid by NASA to do weather forecasting on Mars from Alexandra. He's actually employed by other governments to develop satellites to pinpoint pollution. Now this is amazing, right? Because in many countries trying to work out where emissions are coming from is really difficult. There's corruption, there's all sorts of problems in the way. It's hard to take a device up to a smokestack and test it. Using Greg's satellites and the software, we can pinpoint where emissions are coming from, which means night or day, you know, no matter what the situation is, we can know exactly where emissions are coming from. Sorry. And using satellites, we can use precision agriculture, meaning the environmental footprint of farming is significantly reduced. That's why the government's investing $26.5 million in a new satellite called MethaneSat. Though talking to some people today about the aerospace industry in Christchurch, it would have been lovely if some of that $26 million had gone to New Zealand companies, because we've got a great thriving aerospace sector in Canterbury. I mean, most people would realise this, but we have 5,000 people directly employed in the space economy in New Zealand. It's 1.75 billion to our national economy, but we've only got 0.27% of the global space pie. So we've got a lot of room to grow, and a lot of our companies, such as Dawn Aerospace, who I visited today, are focused on sustainability. And so we've got a great, I think, story to sell the world. Now this is Peter Beck from Rocket Lab, and I'd also like to acknowledge Mark Rocket, who is one of the founders of Rocket Lab, who's here tonight. Now this is an amazing story. You've all no doubt heard of Rocket Lab, but did you know that there are only 11 countries on Earth that have reached orbit? Only 11. We're the only country that did it without a government or military space program. It happened with carbon fibre 3D printed rockets from New Zealand. They're even planning to launch a satellite to the moon next year, which is amazing to think, because you know the dinosaurs might not have gone extinct if they had a space program, but now New Zealand does. And a bit of a personal story about them. So I'm from Gisborne, and the launch site is in Mahi, just down the coast from Gisborne. My mum sadly passed away last year from cancer, and after the funeral we were putting her in the ground, dedicating her to the soil after the funeral. We didn't know it, but at that moment there was a launch from Mahi. So literally as we were putting mum in the ground, we saw this light streak up to the space. It was like mum was off to heaven, which was just a lovely, lovely touch. I also think space can represent the best of humanity. It's actually where governments and cold wars have actually come together and cooperated. And this is one of Carl Sagan's babies, a cosmic metal in the bottle. The golden discs which were put on the Voyager space probes. The idea that if they were ever found by us or other people one day, you could play these golden discs. And there's 115 images, sound of like a mother and her baby and waves, animal sounds, and this.
Hello from the children of planet Earth.
Just beautiful. It's a symbol of all that's good about humanity that we put out into space. You know the great tragedy of it though? Because of bloody licensing issues, they couldn't get a Beatles track on this. So our cosmic message in a bottle does not have the Beatles.
Chuck Berry.
It's got Chuck Berry, that's right. So I'm just about to finish, and I just want to say I hope tonight you've enjoyed, maybe learning something, admiring something about our environment. Because I don't think space ends at the top of the atmosphere. Earth doesn't end at the top of the atmosphere. Space is our environment. And again, acknowledging Margaret Austin, we're so disconnected from our stars in space. Do you know 50% of European Union citizens, 56% of Kiwis, and 2/3 of Americans have lost the everyday ability to see the stars in Milky Way at night. I just think it's such a tragedy that we've lost such a connection with our history, our culture, and also a sense of wonder and inspiration. We can also be proud though that we had the first dark sky reserve in the southern hemisphere. There's lots of other applications on the cards.
Status.
Sorry?
With
gold status. Thank you for that. I'd love to see us set a goal of being the first dark sky country in the world. Now what that means is not getting rid of lights. What it means is using lighting smarter, actually using more efficient lights, which actually saves us money in the long term. But I think that would be wonderful to connect with the stars. So protecting the planet just doesn't stop at the top of the atmosphere. I hope tonight I might have persuaded you to join me in calling yourself an Econaut. We're here in Aotearoa because of the stars that led us here. We're here on this planet because of the stars that died to make us. And if we're ever to travel to the stars one day, we've got to learn the lessons from them. So at the start of the talk, I said I wasn't going to ask you anything to do, but actually there is one thing. I want you after this to go outside and look up. Look up and see what's up there. And look up and think about what's special to you. What's your favourite river or lake or place in Aotearoa? Think about it and think of something, one thing you can do to protect it. Because if everyone did that, if everyone appreciated the beauty and took action to protect it, you know, we would look after this beautiful taonga in the void. This is the last image I've got for you. This is from Saturn. This is us. This is us from Saturn. Again, this was an idea from Carl Sagan, this idea of a pale blue dot. This is us. Let's protect it. Kia ora koutou.